Today we're going to go over 7.2, which is the natural base e. It says the natural base e is irrational and is defined as follows. As x approaches positive infinity, 1 plus 1 over x to the x approaches e. E is approximately 2.718281828846. So e is basically just an approximation of a number. Just like pi is approximately 3.4, e is approximately 2.7. Okay, so a function that is in this form is called a natural base exponential function. It says when a is greater than 0 and r is greater than 0, then we're going to have an exponential growth function. If a is greater than 0 and r is less than 0, then the function is going to be an exponential decay function. Down here is an example of an exponential growth function and an exponential decay function. As you can see, the growth is growing, and then in the decay function, we are decreasing. Okay, so let's do some examples. It says in exercises 1 through 4, we need to simplify the expression. On the side here, I gave you a chart in case you don't remember the properties. The first thing I see is power of a power. So all we need to do is multiply the exponents. So we distribute this 5, 1 times 5, and then negative 3x times 5. Next thing I see is product of powers. So we have the same base and two different exponents. So that means we add the exponents. So we keep the same base, 2, and add the exponents 5 plus 1. Then we keep the same base e and add the exponents negative 15x plus x plus 1. You'd get 2 to the 6 and e to the negative 14x plus 1. For number 2, we can use rational exponent. Our first base is 16 and it has a power of 1. And we're going to put it over 4. Our next base is e. It has a power of 24x. And we're going to put that over 4. Now we're going to reduce. 16 to the 1/4 is the same thing as 2. And e to the 24 over x. We can divide 24 by 4 and get 6x. So that's our final answer, 2 times e to the 6x. Next, I want you to try number 3 and 4 on your own. Remember to use your properties. For 5 through 8, you need to tell whether the function represents exponential growth or exponential decay. Using this formula right here that we got from the top here, we can determine that. Remember that a has to be greater than 0. And then if r is greater than 0, then we have a growth. If we have r is less than 0, then we're going to have decay. So here, starting with number 5, 2 is greater than 0, and r is going to be negative 1, which is less than 0, so that means we have an exponential decay. The next thing we need to do is graph the function. If you don't have a graphing calculator, you can go to Desmos.com and graph it there. Click Start Graphing, and then type in your equation, y equals 2e to the negative x. Go ahead and draw that graph. Let's go ahead and do number 6. On number 6, a is greater than 0, and r equals 4. 4 is greater than 0, so that means we're going to have an exponential growth. Your graph should look like this. Once again, you can use Desmos.com if you don't have a graphing calculator. Now try and do number 7 and number 8 on your own. For 9 through 11, we need to use the table values or graphing calculator to graph the function, then identify the domain and range. So let's go to Desmos. This is what your graph should look like. If you want to see the table values, you can go to Edit List and click Convert to Table. And now you can see what the points are, if that helps you graph it better. The domain for this one is, remember, the x values. So for this one we would have all real numbers because it continues to go to negative infinity and positive infinity. And the range is only the y values that are greater than -4. Let's move on to number 10. So remember, put that in your graphing calculator and graph it and figure out the domain and range. For this one, the domain will also be all real numbers, but the range here, the y values, are greater than 0. Now you try and do number 11 on your own. Okay, number 12 says the population of Evans City is currently at 48,500 and is declining at a rate, declining of a rate of 2.5% each year. You can model the population of Evans City by this equation. PT is equal to PC e to the RT. PC is the current population. PT is the population after 2 years. And R is the rate of change per year. It says predict the population of Evans City after 25 years. Go ahead and write your equation and write down what each one of the variables represents. It says PC is the current population. R is the rate. Remember, we need to change the percent into a decimal. It's going to be negative since we're declining. T represents the years, which was 25. Now plug all those variables back into your equation. If you put that into your calculator, you should get 25,960. Let's move on to number 13. It says your parents will need $25,000 in 10 years to pay for your brother's college tuition. They can invest an account with an interest rate of 9.8 that compounds continuously. How much should your parents invest today in order to have your brother's full tuition available in 10 years? The equation for continuous compound is A equals P e to the RT. Let's write down what some of the variables are. A is the amount they're going to have at the end, which should be 25,000. That's how much the parents need. P is what we're solving for, what we need to start with, so we don't know what that is. R is the rate. Remember to change the percentage to a decimal, so 0.098. And then T is the years. T is 10. Now plug that into the equation. In order to solve for P, we can just divide both sides by E to the 0.098 times 10. Those are going to cancel out, and you're going to get P is equal to 9382.78, and that's in dollars. So they need to initially invest this amount, so in the end they will have that $25,000 to pay for the tuition. And that's it for today's notes.